Hello, my dear children. Today we are going to discuss trigonometric functions. In earlier class, you have already studied. In the 10th class, you have already studied about trigonometric functions. Okay, my dear children. Here also we continue the same topic, same chapter. Okay, my dear children. In the first exercise, that is 3.1. In the exercise 3.1 we discuss these 6 points. Or 6 concepts. We discuss all these 6 points one by one. What are the 6 points? See here. First one, introduction. And the second one, angle. What is meant by an angle? And the third one, units of measurement of an angle. Under this point again we discuss these 2 points, that is degree measure, and second one is radian measure. Now come to the fourth point, relation between radian and real numbers, and fifth one, relation between degree and radian, and sixth one, notational convention. We discuss all these 6 points one by one. Are you ready to listen the class, my dear children? Right. Now come to the first point, introduction. The word trigonometry. The word trigonometry is derived from the Greek words trigon and metron. From the Greek words trigon and metron, this trigonometry word is derived, and it means measuring the sides of a triangle. It means measuring the sides of a triangle. I wrote here, tri means 3, gon means sides, and metron means measuring. These are the Greek words, 3 Greek words, and their meanings respectively. Okay, my dear children. And the trigonometry is the study of relation between the sides and angles of a triangle. The subject was originally developed to solve geometric problems involving triangles. It was studied by sea captains for navigation, surveyor to map out the new islands by engineers and others. Currently, trigonometry is used in many areas such as the science of seismology, designing electric circuits, describing the state of an atom, predicting the heights of tides in the ocean, analyzing a musical tone, and in many other areas. In earlier classes, we have studied trigonometric ratios of acute angles as the ratio of sides of a right angled triangle. We have also studied the trigonometric identities and application of trigonometric ratios in solving the problems related to the heights and distances. In this chapter, we will generalize the concepts of trigonometric ratios to trigonometric functions and study their properties. Okay, my dear children? Right. Now come to the second point, that is angles. Here we are defining angles. Angle is a measure of rotation of a given ray about its initial point. Okay, my children. The original ray is called the initial side, and the final position of the ray after rotation is called the terminal side of the angle. Okay, my children. The point of rotation is called the vertex. There are three parts in an angle. What are the three parts? Initial side, terminal side, and vertex. Understood the points, my children? What is called initial side and what is called terminal side and what is called vertex. Okay, my children? Right. If the direction of rotation is anti-clockwise, the angle is said to be positive. And if the direction of rotation is clockwise, then angle is negative. Okay, my children, see these diagrams. Observe these diagrams. Here, this is a point of rotation. This is the initial side. At the beginning, this is the initial side. After rotation, this is the final position of the ray, that is terminal side. This is the initial side. This is amount of rotation as well as direction of rotation. See here, anti-clockwise direction. So here this angle is measured as positive. Come to this diagram. Here also initial side is OA and OB is the terminal side after the rotation. This is the final position of the ray after rotation. Here direction, this is the amount of rotation and the direction of rotation is clockwise. Okay, my children. So in this case we measure this one as negative. Okay, my children. In earlier classes, this is considered, this is measured as negative. Negative. In earlier classes, we give more importance to amount of an angle, amount of rotation. In earlier classes, we give more importance to amount of rotation, that is 60 degrees, 30 degrees, 120 degrees, like this only. But in this higher classes we give the importance to amount of rotation as well as direction of rotation also. We should give importance to this point also while you are measuring an angle. Okay, my children, keep this point in your mind. Okay, right. The measure of an angle is the amount of rotation performed to get the terminal side from the initial side. There are several units for measuring angles. We shall describe two units of measurement of an angle which are most commonly used. Which here which means namely they are the two units of measurements are degree measure and radian measure. So now we are going to discuss these two units of measurement of an angle. Okay, my dear children, right. Now come to the first unit of measurement of an angle, that is degree measure. Degree measure. If a rotation from the initial side to terminal side is 1/36th of a revolution, the angle is said to have a measure of 1 degree. Okay, my dear children, revolution means if the initial side and the terminal side coincides after one complete rotation. One complete rotation is said to be a revolution. Then the amount of rotation is divided into 360 equal parts and one part is said to have 1 degree. It is said to be 1 degree and written as 1 degree. You know this one. In the earlier classes you have already learned. 20 degrees, 30 degrees, 40 degrees, 50 degrees, 90 degrees. Okay, my children. And now a degree is divided into 60 minutes. So here 1 degree again it is divided into 60 equal parts, and that one part is said to be minutes, and a minute is further divided into 60 seconds, and 1 minute again it is divided, that amount of angles further divided into 60 equal parts, and each part is said to be 1 second, so 60 seconds. This minute and this second, these two words not related to time. Here these two words related to measurement of an angle. Remember this point, my dear children. 1/60th of a degree is called a minute, written as 1, like this. Okay, my children, remember this notation. And 1/60th of a minute is called a second, written as this, like this, 1 second. This denotes 1 minute, and this denotes 1 degree. Okay, my children, remember these notations: 1 degree, 1 minute, and 1 seconds. 1 second. Okay, my children, right. Thus, 1 degree is equal to 60 minutes, 1 minute is equal to 60 seconds, and one right angle is equal to 90 degrees. Remember these points in the degree measure of an angle, my dear children. Okay, my dear children, understood? Right. Now come to the next measurement, next unit of measurement of an angle. That is radian measure. This is second unit of measurement of an angle is radian measure. There is another unit for measurement of an angle called the radian measure. This is second unit of measurement of an angle. What is this called? Radian measure. An angle subtended at the center by an arc of length 1 unit in a unit circle. Here unit circle means circle of radius 1 unit. Is said to be a measure of 1 radian. Okay, my children? Right. Now observe these four diagrams, my dear children. See the first diagram. Let us discuss about the first diagram. This is a unit circle. Unit circle means radius of this circle is 1 unit. So OA is a radius and OB is also radius, 1 unit. Okay, my dear children. Now arc AB, the length of the arc ABA is also 1 unit. Length of the arc AB is also 1 unit. So this arc is subtending some amount of angle. This arc AB is subtending some amount of angle at the center of the circle. This amount of angle is said to be 1 radian. And here direction of the rotation is anti-clockwise direction. So we measure it as a positive. Understood these points, my dear children? Here length of the radius is 1 unit, and length of the arc AB is also 1 unit. This arc AB is subtending some amount of angle at the center of the circle. This amount of angle is said to be 1 radian, and the direction of the rotation is anti-clockwise direction. So we measure this angle as 1 radian. So come to the second diagram. Here also the same amount of angle, same length of radius 1 unit. Here also 1 unit. Length of the arc AB is also 1 unit, and observe this one, direction of the rotation. If you observe the direction of the rotation, it is clockwise from A to B, clockwise direction. So we measure this amount of angle as negative. So -1 radian. Here and here also amount of angle is same, but direction is different. Understood these two diagrams, my dear children? Right. Now come to the third diagram. In this diagram also, radius of the circle is 1 unit. That is, this is also a unit circle. But length of the arc is 1.5 units. What is the length of the arc AB here? 1.5 units. Then this arc AB is subtending some amount of angle at the center of the circle O. This amount of angle is said to be 1.5 radians. What is the amount of angle here? 1.5 radians. And if you observe the direction of rotation, anti-clockwise direction. So we measure it as a positive angle. So 1.5 radian. Now come to the fourth diagram. Here amount of rotation is same, 1.5 radians only, but if you observe the direction of rotation, the direction of rotation is clockwise direction. So we measure this angle as negative. So the angle is here minus 1.5 radians. Understood the points, my dear children? Right. The above figures 1, 2, 3 and 4 show the angles whose measures are 1 radian, minus 1 radian, 1.5 radian and minus 1.5 radians respectively. Understood this point, my dear children? Right. We know that the circumference of a circle of radius 1 unit is 2 pi. This is the circumference of a circle of radius 1 unit. Thus, one complete revolution of the initial side subtends an angle of 2 pi radians. Understood this point, my dear children? Right. More generally, in a circle of radius r, an arc of length r will subtend an angle of 1 radian. Okay, my dear children. In the previous figures, we have taken 1 unit. We did not mention how many centimeters. One, it may be 10 centimeters or 20 centimeters. 1 unit can be taken. Okay, my children. If you take radius 1 unit is equal to 10 centimeters. Then length of the arc also should be 10 centimeters. Like this. So if the radius is r centimeters, then arc of the length also r centimeters. Then that arc subtend an angle of 1 radian at the center of the circle. Understood this point, my dear children? It is well known that equal arcs of a circle subtend equal angles at the center of the circle. This is a theorem you have already studied in the 9th and 10th classes. Equal arcs of a circle subtend equal angles at the center of the circle. Since in a circle of radius r, an arc of length r subtends an angle whose measure is 1 radian, an arc of length L will subtend an angle whose measure is L by R radian. Thus, if in a circle of radius R, an arc of length L subtends an angle theta radians at the center, we have theta is equal to L by R or L is equal to R theta. Remember these equations, my dear children. These are the relations between radius of the circle, length of an arc of the circle and the angle subtended by the arc of the circle at the center of the circle. Understood, my dear children? Right. Now come to the fourth point, relation between radian and real numbers. Here we are going to discuss between the relation between radian and real numbers. Observe this figure. This is a unit circle. Radius of this circle is 1 unit. Okay, my children. And here a tangent is drawn at the point A. OA is a radius. At this point A, we have drawn a tangent PAQ. Okay, my children. Consider the unit circle with the center O. We have considered a unit circle with the center O. Let A be any point on the circle. Here A be any point on the circle. Consider OA as initial side of an angle. We consider this is the initial side of an angle. Then the length of an arc of the circle will give the radian measure of the angle which the arc will subtend at the center of the circle. Okay, my children. Consider the line PAQ which is tangent to the circle at A. This is a tangent to the circle at A. PAQ. This line is a tangent to the circle. Let the point A represents the real number 0. AP represents positive real numbers and AQ represents negative real numbers. Okay, my children. If we rub the line AP in the anti-clockwise direction along the circle and AQ in the clockwise direction, then every real number will correspond to a radian measure and conversely. Thus, radian measures and real numbers can be considered as one and the same. Okay, my children, this is the relation between radian measures and real numbers. Now come to the fifth point, my children. That is relation between degree and radian. Okay, my children. Here we are going to discuss the relation between degree and radian measures. Since a circle subtends at the center an angle whose radian measure is 2 pi and its degree measure is 360 degrees, it follows that 2 pi radians is equal to 360 degrees. This is the important relation between radian measure and degree measure, my children. Remember this well. Okay, my children. Or pi radians is equal to 180 degrees. The above relation enables us to express a radian measure in terms of degree measure and a degree measure in terms of radian measure. Okay, my children, with the help of this relation between radian measure and degree measure, we can convert radian measure into degree measures and we convert degree measures into radian measures of a given angle. Okay, my children, right. Using approximate value of pi as 22/7, we have 1 radian is equal to 180 degrees by pi, that is equal to 57 degrees 16 minutes approximately. Okay, my children, this 1 radian is equal to 57 degrees 16 minutes approximately. Remember this value, my children. Also, 1 degree is equal to pi by 180 radian. That is equal to 0.01746 radian approximately. So, 1 degree is equal to 0.01746 radians. Okay, my children. The relation between degree measures and radian measures of some common angles are given in the following table. Throughout this chapter, throughout this trigonometric functions chapter, you should remember the relation between degree measures and radian measures. 30 degrees is equal to pi by 6 radians. 45 degrees is equal to pi by 4 radians. 60 degrees is equal to pi by 3 radians. 90 degrees is equal to pi by 2 radians. 180 degrees is equal to pi radians. 270 degrees is equal to 3 pi by 2 radians. 360 degrees is equal to 2 pi radians. Remember this table, my dear children, throughout this trigonometric functions. Okay, my dear children, right. Now come to the last point, that is the sixth point, notational convention. Okay, my dear children, since angles are measured either in degrees or radians, we adopt the convention that whenever we write an angle theta degrees, we mean the angle whose degree measure is theta. And whenever we write an angle beta, we mean the angle whose radian measures is beta. Okay, my children. Note that when an angle is expressed in radians, the word radian is frequently omitted. We don't use the word radian. Thus, pi is equal to 180 degrees, means pi radians is equal to 180 degrees. Observe here, my dear children, we did not write the word radian. Similarly, pi by 4 radians is equal to 45 degrees. Have you observed here also? My dear children, we did not write the word radian. Pi by 4 means pi by 4 radians only. Okay, my dear children. Or written with the understanding that pi and pi by 4 are radian measures. Thus, we can say that radian measure is equal to pi by 180 into degree measure, and degree measure is equal to 180 by pi into radian measure. Remember these 2 points, my dear children. These are very useful to convert an angle which are given in the radian measure into degree measure, and if you want to convert an angle in the degree measure into radian measure, these two are very important points. Okay, my children, right.